Hello, this is Michael Osborne with Webucator. In this video, we're going to take a look at the differences between casting in .NET and the .NET as keyword. Now, this video is based on a blog entry by John Skeet. John agreed to let us create this video discussing his article, which is available on his blog at the URL you see here. Okay, so there are lots of different ways to cast variables in .NET, and for the most part, we all kind of understand that. What we're interested in discussing in this video is one particular scenario. This is a situation where we have an expression which is of one reference type, and we want an expression of a different compile time type, but we don't want to change the actual value. Essentially what we want is a different view on a reference. Now, to accomplish this, there are two possible approaches. One is to use an explicit cast. The other option is to use the as operator. Now, in the code you see on the screen here, I begin by declaring a reference variable of type object, and what I assign to it is an instance of a string, in this case foo. So I could explicitly cast it by simply doing a string cast, and in that case, if x is not a string, in other words, if it cannot be cast to a string, what I will get is an exception. The alternative is I could use the as operator. So in the third line of code here, you'll see I declare a string as operator reference variable, and I assign to it x as string. Now what this will do is, if x can be cast to a string, it will store the reference in the reference variable. If it cannot, it will simply store null. Now many developers will tend to lean on the as operator as much as possible. The argument being that exceptions are expensive, we should avoid them at all cost. The problem with this is that there are some scenarios where an exception actually would be better than ignoring the fact that that variable cannot cast to that type. So what we're going to do is we're going to look at some examples that kind of illustrate this point. So let's begin by looking at a case of unconditional dereferencing. Suppose you have a form, and on the form you have some buttons, a number of buttons in fact. They all share a single event handler, and that event handler, all it does is change the text of the button to clicked. Now there's a couple of different ways we can approach this. In the first example, you'll notice that in my code I receive an object of sender, and I do an explicit cast to a button, and then I set the button text to clicked. In the second case, I receive an object sender. I then use the sender as button syntax to assign it to a button, and then I set the button text dot clicked. Now, in both cases, when the sender is in fact an instance of a button, the code's going to function correctly. In both cases, when the sender is null, both will fail with a null reference exception. But when the value of sender is a reference to an instance that isn't compatible with button, a text box for example, we're going to have some different behavior. In the handle using cast, the first line will fail by throwing an invalid cast exception. In the handle using as, the second line will fail, giving us a null reference exception. Now, which of these is the preferred behavior? Well, it seems pretty obvious to me that my preference would be to receive an invalid cast exception. This gives me a lot more information than a null reference exception. But if you look around, you'll find lots of sample code where people say, oh, I always prefer to use the as because I avoid the exception. Bottom line, you're always going to get an exception. So there's really no reason here for us to use the as. We should always, in this case, do an explicit cast. Now, some developers will still argue that rather than doing the explicit cast, you should go ahead and use the as keyword, but you should modify your code so it looks kind of like this. So essentially by doing this, what I'm saying is that If the object being received is not a button, I should essentially ignore it. And I have a little typo there I need to fix. There we go. But there's a couple of problems with this. Now, first, let me point out that this is really the situation that the as keyword was defined for or designed for. If you had to choose between one of these implementations, I would pretty much always go with the as keyword. But let's be honest here. How likely is it that in a button event handler, you will receive a sender which is not of type button? And quite frankly, in a situation where you receive a non-button sender object, wouldn't you prefer to know right away via an exception rather than delaying and having that problem caught later in the code when there may have been some other changes made that maybe you can't recover from? So if you're going to do something like this, as a minimum, be sure you log this particular error. So you would do something like this. And therefore you have that at least some information that that error occurred. Now, in the previous two examples, we were looking at situations where it made more sense to use the explicit cast and to receive the exception than to use the as keyword and avoid the exception. But that doesn't mean that there are no scenarios where as makes sense. For example, suppose we're doing equality testing. Here I have a class called foo. Foo implements the I-equatable interface of type foo. And you'll notice we have an override of the equals, which receives an object, and then we have a bool equals, which receives foo. Now the idea here is this: when you call this class, you could pass in an instance of foo, or you could pass in null, or you might pass in something which is an object but is not an instance of foo. So we need to be able to deal with all those possible scenarios. So essentially what we've done here is we are delegating the equals foo method, or to the equals foo method, which then is responsible for handling the nullity, but it doesn't really need to worry about any non-foo references. We're anticipating that we might receive a non-foo reference in the equals object method. And in fact, the documentation for this method explicitly states what we're meant to do. So this doesn't necessarily mean it's a programming error. It's just we might receive a non-foo reference. Now, you could also have implemented this like this. Which is just implementing the equals with a cast. Now, the next case we may want to consider is a situation where we might want to defer or kind of delegate the decision down the line. Suppose, for example, we've got some methods coming, some parameters being passed in, and it may be valid for those parameters to be null. For example, here I have a definition of a person class. I'm not going to get into the details of that, but I have two methods. One creates person with a cast and the other creates person with the as keyword. In the first case, we receive two parameters and then we cast them to strings. If those parameters cannot be cast to strings, we will get a argument exception of some sort. On the other hand, in the second method, we take those two objects and then we cast them using the as keyword. Now, the effect of this is that we can create a person object where the first name and the last name parameters are both null. And that might possibly be valid, but what is the chance that somewhere down the line some code is going to expect those to be non-null values? And what are the chances that between now and that point the code makes some changes, potentially irreversible changes, before we run into that problem? So we could have some serious issues here, some data loss, corruption, that sort of thing, because eventually we're still going to get that exception. It's just we're not handling up front. We're passing it or kicking the can down the road, if you will. Now let's look at one last scenario where the as word can in fact be very useful. Suppose, for example, you have an input, an object being passed in that Well, the classic example is a collection. Let me get my code up here. Suppose I have a collection being passed in, and I know that the collection implements IEnumerable, but it's also very possible that it will implement iCollection. Now, iCollection gives me a lot more behavior, useful behavior that I can leverage. So what I could do in this scenario is I could use the as keyword to attempt to cast the object being received as a type iCollection of type string. And then I could check and see if it's null. If it's not null, I would leverage that iCollection interface. Otherwise, I would go back and kind of do it the long way around. I would do the get enumerator and the move next and all that other stuff. So again, this is a scenario where as is very useful because we can potentially take a shortcut, if you will, to some optimized implementation or behavior. So to summarize, the as keyword, while certainly useful, is not a panacea that fixes all your problems. Be careful about falling in that trap of assuming that anytime you avoid an exception, you're doing a good thing. There are certainly scenarios where we prefer to receive that exception early and handle it rather than propagating those problems down the line and having them create even more problems further in the code. Okay, I'd like to again thank John Skeet for the inspiration for this video. Be sure and check out his blog at the URL you see here for other articles related to programming in .NET. That's it for this video. I hope you enjoyed it.